Okay, we have our review for CFA over 1.3 and 1.4. So let me get my name here. We'll get started with our parent functions and the transformations of our graphs. So as we do these, a quick recap. We have our parent function, which we called h of x is equal to a times whatever our function is, our parent function, but it has a coefficient b times the quantity x minus h, and then at the end we have our plus k. So that's our parent function, our general transformation equation, and then we're given a function, parent function, and then if we have any of those coefficients filled out, then that does actually change the shape and look at the graph. So if we start with A, it's asking us, given the parent function f, write a rule for the transposed or transformed graph h of x. So again, on the margin, here's what I always do. Start by just identifying the coefficient. So we'll do that based on the descriptor. So recap, A does vertical stretches. It is by a factor of absolute value of A. So if A happens to be negative, the vertical stretch factor is just the absolute value. If A is negative, that's when we get a reflection across the x-axis. The H in our list here would be our horizontal translation. So that would be sliding it, shifting it left or shifting it right. If H is positive, we would have an x minus H. It's kind of counterintuitive, but if H is positive, so we have an x minus H, so x minus 5, then our shift is to the right. If our H is negative, first off, our equation becomes x plus our H value, because x minus H is negative, the two negatives turn to a positive, so x plus 5 would be a shift to the left 5. Then we have B. B stands for our horizontal stretches. And this is a tricky one for how much it stretches it. So the horizontal stretch might be, the B might be 2. If B is 2, we would say that the graph is horizontally stretched by a factor of 1 over B, or in this case, 1/2. If B is negative, what we get is a reflection across the y-axis. And then K is just our vertical translation. Does it shift up? Does it shift down? And that's direct, positive K is shift up, negative is shift down. So now that we have that, let's look at our example A. Reflect across the x-axis. We decided that's when A is negative. So I'm going to start with giving A a negative. It stretches vertically by a factor of 1/2. Our vertical stretches by a factor of absolute value of A. Our factor is 1/2, so A is just 1/2. So the value is going to end up being negative 1/2, but the stretch factor is 1/2. Shifting right 4 units. If we shift right, that's positive H, H is 4, over there. Stretch horizontally by a factor of 5. So that is that idea of by a factor of 1 over the absolute value of B. So that actually is, they're saying this is 5. So if 1 over B equals 5, then B must equal 1. And we also have a shift down 3. K is negative 3. Okay, with that said, we've identified our coefficients. Let's write the equation. So A goes out front, so h of x is negative 1/2 f of B, so 1/5 x minus h, so minus 4, and then plus k, which is negative 3. So negative 1/2 f of 1/5 of x minus have checked off, stretch, shift, stretch, shift. There we go. Moving on, number 2. Start with our A, H, B. All right. Shifting right 2 units, H equals 2. Check. Stretch horizontally by 1/3. Horizontal is our B coefficient, and we know that our stretching is 1 over B is 1/3. Therefore, B is actually 3 in this case. Okay, stretch horizontally by 1/3. Stretch vertically by 8. So that's just a direct translation. And then shift upwards 1, K is equal to 1. So let me get rid of those dots. Okay, so we would write this as H of X is equal to 8 F of 3 of X minus 2 plus 1. There we go. We've got all of our factors. All of our factors accounted for. Shift, horizontal stretch. Yep, perfect. All right, here's your answer. We're just going to keep rolling here. Number 2, A, B, and C are the opposite. It's given translated function and transformed. Now you have to describe what happened. So the way we did this in class before was to go through the order of operations for multiple transformations and describe them as they would happen. So the steps for multiple transformations are horizontal shift, then stretches, then reflections, and then vertical shifts. So if we look at those, if we have one, great, we'll write it down. If we don't, we go to the next step. In that regard, you look at A. The first thing we have to do is get this into standard form, that standard form from up above. A times F times B of 8x minus h. We cannot have a coefficient or negative sign in front of our x. So let's rewrite this quickly. -1, and I will put the 1 just to make it distinct. Now we have standard form. Now we can proceed to describe the transformations. So our horizontal shift that did affect it. Let's go ahead and identify all of our coefficients. H is 4, B is -1, K is 1. So when we look at this, we say shift right by 4. There we go. So we got our horizontal shifts. Our stretches, do we have any A's or B's? Yes. We have a vertical stretch. We say that's by a factor of, or for my case, just by vertical stretch by 0.5. We do have a B value with 1, so our stretch is by factor of 1, so we won't say that. A reflection we do have. And because it's on B, when B is negative, that's a reflection across the y-axis. And then we have a shift by 1. Okay, moving on. B, I have to rewrite B also as -f of 2 of x plus 9. Now we have our standard form, a f of b times x minus h plus k. K is 0. So a is -1, h is -9, b is 1/2, because remember it's kind of the reciprocal, and k is 0. So we have a shift left by 9. We have our shifts taking care of stretches. We do have a stretch. Sorry, that's a horizontal stretch by, I'm sorry, I messed that up. Let me correct this very quickly. Get my Okay, well, it's not letting me go to my eraser, so I'm going to scribble that out. Our b is directly given to us, and that is 2. So that's my fault. Please correct that. Our b is 2. It's given to us in the equation. The horizontal stretch by a factor of, that's where we would say by 1/2. That's my fault. Sorry about that. I'm just trying to demonstrate. We all make mistakes, right? Okay. Let's see. Horizontal stretches. There's no vertical stretch because a is 1. Our reflections, we do have a reflection across the x because our a is negative. We have our horizontal shift of 9. We have our stretches taking care of our reflections, and we have no vertical shift. So we are good to go.